Today 3D printing has a potential in every aspect of manufacturing, and this is a unique initiative and which I feel would help each and every seeker in this domain to further his interest and grow the technology.
It is going to bring about a revolution. You can think that a world without a disease, without disability.
Today I can say that whatever that you can imagine can be actually put into practice with the medium of a software to print or give substance to your ideas with the help of 3D technology.
It's been our conscious effort in terms of want to communicate and create the awareness.
Help us innovate faster and better. And it's easy for people to access it and make interesting products out and take their imaginations into reality.
This is a platform where we can promote these technologies.
For a simple reason, because 3D printing is a technology which is going to change the way things are.
Respondents of 3D Graphy News, welcome once again. And now we have an opportunity to discuss the medical aspects of 3D technology. For those who are connected first time, 3D Graphy News is a platform that we've designed for promoting 3D technology. Now, 3D technology constitutes of 3D printing, 3D visualization, that is to do with AR and VR. We also have 3D simulation, which is very, very important, 3D software, 3D imaging, and 3D scanning. And very important is materials, because it all constitutes to all of these to ensure that how the technology can be well utilized by various different sectors. Name it dental, maxillofacial, prosthodontists who are using this technology to an extent in terms of planning. Orthodontist, implantology is also being taking a very good value proposition from this technology when it comes to surgical guides and stents and various solutions. And also when it comes to orthopedics, spine surgery, all of these specialization needs 3D technology, because when it comes to customized solution, 3D technology is the only solution today which is actually available, which can actually make things more easier and convenient for doctors and surgeons. And here is a platform, 3D Graphy News. The conscious effort is to be an information source for doctors and surgeons and researchers and material scientists, and also 3D technology companies to know what is the end user's expectations in terms of offering these solutions, so that the end, the patients get their quality services through our platform. So that's where the conscious effort with 3D Graphy News is. So here is a great opportunity for us to connect with Dr. Pranav Sapkal, who is the founder of the company Lucid. Now, Lucid is a company offering solutions in 3D printing solutions in implants and also in the medical space. Predominantly, it's been into head and neck in terms of the value addition that they've been actually making, and also for PSIs, which is also called patient-specific implant. Doctor, very good afternoon to you. It's a great opportunity to connect with you. May I now like to ask you to introduce yourself and also give us a glimpse of where it all started. Why 3D printing or why 3D technology? Please, Doctor.
So actually, I'm a mechanical engineer. I did my graduation from College of Engineering, Pune, and then I did my MTech in CAD CAM, which is all about the softwares. However, then I got a project. My professor got a project called BETIC Biomedical Engineering and Technology Incubation Center of IIT Bombay, and that project included three institutes, that is COE Pune, VNIT Nagpur, and IIT Bombay. That was the year 2014 when the government changed, and the government gave around 39.39 crores to IIT Bombay, and the agenda was just to go. Whatever students are coming, we are not interested in any research work or a PhD that you are getting. We are not giving this money for that. Whatever projects that you are taking, the output should be in the form of a company. That's it. And then Professor Ravi started that project. And I think we got around 3 crores out of that 39.39 crores. And Professor Kute said that, okay, I'll go for the class 4 devices. And Professor Ravi and IIT Bombay and CAP decided that they'll go for class 1 and 2 devices, class 2. Class 1 is just like a thermometer or a stethoscope. However, class 3 or class 4 devices are implants which are inside the body and will be inside the body. So that time I was exposed to the project name was tissue engineering. I was not aware about anything, but slowly I started learning that. And in 3 4 years was a good time of PhD that I understood all the anatomy and how the thing worked. So a lot of time was required just to know about a single thing, that is only the CMF implants. Even if I go for spine, again I need to have so much time. Now we are into orthopedics, as I told you, that we have installed one of the facility, and there we are working on the resection guides for total knee replacement and hip replacement. Again, that is, the doctor is very much important because he is the one who is going to tell the engineer how the things will be. So when we make a guide, it's he who tells us. They have a big sort of a drill and what the vibrations are. Then you actually come to know how your implant should be or how sturdy the guide should be. This is not possible when you are in academics, because in academics, in 4 years of time, you do one surgery, and when you have a company, you do so many surgeries in single day, because actually people are paying you. So this is about the background, and this is how we went into this. And Prashant was also the second founder, was very much inclined towards this area. However, he said that I'll not be managing the operations. I am interested more into the finance and the business model and things like that. So that is also one of the person which is required to run the company, because he is the one who brings the money. And the third, the technical end, because when you make any implant, who is the person who is watching for you? A doctor who says that I have used the implant and it's good, you can also use it. Because you cannot say in the market ki my implant is good. The doctor will not listen to you. The doctor listens to the another doctor who says that his implant is good. So that initial mistakes that you do is you should have a surgeon with you. Okay, so actually, it started when I was doing my PhD from VNIT, and I was doing it on bioprinting. So you must be knowing that after 10 years or 15 years down the line, implants will be replaced by actual tissues. So when there is a cancer in the mandible, what we generally do is we place the implant. However, bone has to be replaced with the bone and not with the metal. Now that is the future of reconstruction, and I was working on patient specific scaffolds, which are bone regenerating materials at that time. So this is how we went into this area. However, there is no commercial value uh, uh, to bioprinting as of now. It is at a very research stage. And as you know, titanium or some of the polymers which have commercial value, we came to know about these things when we I was doing my PhD, and we interacted with one of the surgeon. His name is Dr. Nitin Bola. He's also one of the director of the company, and then he said, "Ki, actually, this is the place where you'll get the money. However, that is under research. It has some 15 20 years time where will people will, because that is very expensive treatment. And then we decided that okay, that will be the research end, but till that time we were very uh, aware about how the surgeries happens, and what is the protocol for the surgery, what kind of implants are required, what is the basic anatomy, and what is the market for CMF implants like craniomaxillofacial implants. It also covers neurosurgical implants as well as plastic surgery implants for aesthetic reconstruction. Now, this was our area in which I was working, and then I segregated ki in this area I can sell these implants, and then this is how we started.
So now, so as a company, what is the size of the company? As in, do you have more directors on board with you, and uh, is it a structure wherein you needed investments to start? How did it all start? So the audience would also want to know in terms of for somebody who has been able to structure a well-defined company like Lucid today as a service provider. How is it for somebody who would want to start, and what are the challenges, or it seems much of the challenges not being to an extent in terms of the investment, but I also to understand, is there an investment when it comes to the machines currently, or maybe the software, or do you need a team of designers, because everything is to do with your design construct, understanding the anatomy, so biomedical engineers so yeah, just to give a better idea in terms of the structure.
Yeah, so actually, we are three directors in the company, me, Prashant, and Dr. Nitin Bhola. One of the surgical, whenever you are working in a medical technology company, it's better to have a surgeon with you. Now, as far as the investment is concerned, for patient specific implants, the investment is see, I'm from the operations background. I might not be able to give you the exact numbers, but at least it is a bit low as compared to that of the standard implants. Now, standard implant is like something in which you are making the implant in masses. So, if suppose I am making a hip joint or a knee joint, I need to produce it in masses, and for that, there are so many regulations. Whereas for PSI, that is patient specific implant, will be specifically designed for that individual patient, and hence the doctor is the final authority for the design confirmation. As far as the softwares are concerned, medical softwares, like there are two companies, one is Geomagics and one is Materialize. Uh, Softwares are a bit expensive, some are perpetual and some are yearly based, so it depends where you want to go. But the main challenge is not only with the investment. There are people in the market who they have money with themselves, but when it comes to medical technology, you really need to know in detail about the biological aspect while designing any implant. Like for example, for the mucor cases, as you know, in India there are so many mucor cases, and what happened is initially we were not having any solution. 5 years before, these implants were imported from Belgium, and the implants were imported. Here, the surgeon used to send the CT data to Belgium. They used to design it. Then the implant used to come after 3 months of time. Then it has to clear custom duty, and when it reaches the patient, it's around 4 months of time. Now, because of medical tourism, if you think that maximum patients they go to Mumbai. However, see, in Mumbai, the patients are not from Mumbai. They are coming from Jabalpur or Nagpur or Calcutta just because Mumbai has good facility. But now with PSI and with the disruption of the technology, there are so many people who are getting inside this. And in India, what happens is that if something is getting famous, so many people jump into that. So it is good that so many people are coming, and this eventually reduces the cost of the imported implants. As far as the designing aspect is concerned, if you are in CMF, craniomaxillofacial implants, at least like I am in CMF implants from last 7 years. Out of it, some of the time was in my PhD. So lot of design iterations, and daily you will be seeing that there are so many design iterations which doctors are coming and the engineers are coming with. 1 month before the implant that I designed will have a different design, and later on we as well as doctor comes to know that okay, Pranav, this is what the modifications that we both think has to be done, because this has some repercussions, this should not be like this, and they also are getting to know about this. That is why in medical technology, or when doctor says, if you ask any doctor, he'll always say that I am doing practice. That is why it is called as practice in surgery area. It's never perfect. It's like they are doing so many surgery, and that is why they call it as a practice. So software investment is there. You need to have your big facility. ISO 13485 is required. Clean room, that is ISO 7 is required. You need to have the documentation of each and every implant. You need to maintain the sample of every implant, and it's not nothing like that. If you are in orthopedics, again you have to spend 3-4 years, like KLS Martin does. And if you are into that, then again, if you want to go into heart specialty, again you have to. So a lot of investment of time is required when the company is working on deep tech technology. So you really need to know, when the doctor is talking with you, will come to know that how much you know, because he is taking that risk of putting your implant into his patient. So instead of investment, I would say definitely investment is required, but I would say that deep knowledge will be required depending on the patient, so that the doctor should come to know. So now in mucor cases, you have some implants, then the doctor will say ki, acha, but the patient need the teeth also, so that he can eat also. Then you need to provide, but that area comes under prosthodontist. So different area in dentistry are there, and you need to provide solution. Then because the surgery costs around 5 to 7 lakhs, and if the patient is investing that much of money, he definitely expects that the surgery should be fine, and he should be able to have a better life after that. Yeah.
So, Doctor, yeah, I understand. More than the investment, it is also the technique and the understanding of design for biomedical engineers to see that how they can be well tuned to the requirement, for because every customer, every patient is different, anatomy is different. Every case, for that matter, if you're only talking about a mandible reconstruction or a TMG requirements in terms of implant, even there too it is different because the sizes do vary. So it's as body is as complicated as it can be but it is now made easy with 3D technology to an extent wherein doctors and biomedical engineers and companies offering solutions like yours can come together and maybe effectively ensure that the procedure is faster and efficient compared to the modular implants earlier. So now it is customized, it becomes convenient. So as you rightly said, every stages would need its specialization and his attention. Very, very important. So what do you think on the larger context? Do the educational institutions, when it comes to medical education, would also need 3D technology? Do you also support uh, an interest to see that the new aspirants also need to be educated on this aspect? Because I am sure to set up an organization, the clear intention is to also, it's more like a service to be offered to mankind. So, do you think that the next generation and students from PGs from colleges also need to be updated of this technology? And how do Lucid? I mean, what is Lucid's role there? Is there an extent of arm that you also have in terms of offering, in terms of your time to go and train these respondents? I'm sure with time, as the organization also grows, you also need those resources. So it is also coming from these institutes. I'm looking at a larger perspective.
Yeah. So see, as far as the institutes are concerned, uh, they need to be trained, and 3D printing, as I said, is just another manufacturing technique, which is far much simpler than the traditional techniques. So if we talk about CNC machining, you need to know the programming and things like that, but if you have a 3D printer, only 2 hours of training is sufficient. That is why 3D printing is just a manufacturing tool. Now as far as the students are concerned in the colleges, they should be trained for that. What generally we do is that we go there and we give some lectures. We also attend some of the conferences, like for craniomaxillofacial area, AMSI is the conference which happens every year. Last year it happened at Mangalore, and in this year it is happening at Indore. Also, there are state chapters like in Maharashtra. Similarly, you have conferences for orthopedics as well as for plastic surgery department and neurosurgical. So generally, companies like us, we just go there and we present there. In our company, what we do is that whenever we have a case, we write so many blogs and we take the surgery photos from the doctor and we tell him ki you can publish it from your LinkedIn post and you can post it. What happens is that what is lagging in the medical colleges that I think is students are very they are more inclined towards the customary things that people are doing. So in a medical college like government colleges, there are so many patients and these PG students have their shifts. Lot of students are you know reluctant, or I think are not ready to put on any money on the research end. For them, it's just a project. They are more inclined towards the regular thing that they are doing. So, however, when they are doing that surgery, one surgery is equivalent to one research paper. But if you ask these students, they are doing so many surgeries, but they don't write those research papers. So what I'm saying is that they are doing this much amount of work, but the output they are taking is this much because they're not putting the equivalent time on publishing the blogs, writing the paper, writing the technical thing, submitting the FEM analysis reports, and submitting into a better journal is the one thing which is required from the colleges. uh, some of the colleges are also responsible for that. They give so much burden on the students and things like that. But definitely now, you know things are changing a little bit. And for TMJ cases, we suppose there are some companies which provide TMJ joints, and when you fix those joint, you need to do a lot of manual editing in the bone. So you're not fixing the implant on the bone, you're fixing the patient on the implant. So you edit the bone on the patient, which increases the surgery cost, the anesthesia cost, the complications, and how better a doctor is how good he engineer, or how he wonderfully does the surgeries. But PSIs reduces the time. A lot of things like mock surgery or virtual surgical planning reduces or gives the surgeon the overview that how the output will be. And as far as college is there, one more problem that I see is, see what happens now. Like you recently, we have seen that Air India was again procured by Tata's. So what happens is that the government should not be in the business of business, because they they are unable to run it. In a business, it's an engine because that is the money. In colleges, there are so many colleges, and that is why we started this thing called as Lucid Astel. So Lucid Astel is some of the program in which we said that okay, in any college, Lucid will be investing the money for the machines, and Lucid will keep one person in the hospital. His duty will be just to collect the DICOM, and he will be designing everything. The designing hub will be in the company, and just the the planning time, which is the 90% time of any surgery, is planning, and 10% is just the surgery time. But that 90% time is like he's giving me the order, then I'm printing the model, then I'm couriering it. It requires 3-4 days, then it reaches there, then they do it, then they say, no, Pranav, this has to be done like that. Then again, the model comes and things like that. This has a it wastes so much time actually. So what we decided is that how if we have this facility in the hospital, this transportation time can be reduced, and the doctor can say that okay, if it's a malignancy case, suppose, acha, just get me the model, I'll see. Then he can plan the resection cuts. Then again he say, no, Pranav, I think I need the guides also. Again, the guide can be mailed, because this mailing is easy. You don't require any time, but courier will take so much. Then they will receive. Then this manual error will come like that. And companies like us or any company doesn't have that much system like Amazon does, transportation system. So that we are reducing, and this is how when the students have the facility in the college, they can go and they can see the things, how things are working. They can have the exposure, because city data doesn't gives you that 3D reconstruction, but the college also has to be upgraded. That even in some of the government colleges like AIMS, they are saying that we have the money, we can buy big machines, but who is going to maintain it is the question. And in government, when the material finishes, then you have a lot of process to procure it. Then this is how the system doesn't run. Actually, this is what I'm saying, that there is no individual responsible person who says that I will be doing this. Then if suppose some maintenance happens to the machine, then again there is a big process which requires 3 4 months. And in government you'll see that the machines are just kept like that. They have money, but the utilization is not that much, so they are not able to exploit the machines for which they have done the investment.
So, Doctor, you are also working as a catalyst in that direction in terms of also helping these institutes to look at an option wherein they don't probably need to invest, but you are also like an outsourcing model of for services. Is that also the
Exactly.
case?
So what we did is, like, HCG is a oncology cancer chain, as you know, all over India.
Yeah.
We installed our first facility at SCG Nagpur because we are from Nagpur. So we thought that okay, we'll have the first facility in Nagpur. Second facility we installed at Orthomax Hospital, Varanasi. So that is there. We are also talking with other people. We are just seeing what is their interest. See, we also need to see the volume that they have, and regularly our machine should be able to this thing. They should give us the space and things like that. So this we are evaluating under Lucid Astel, that how can we, you know, expand the things by having individual facility, basic individual facility, not the titanium printers. You cannot install 5 crore printers in 100 hospitals, but they can have the 3D printing lab, like you have the medical store in the hospital, or the CT scan department, or the pathological department. There should also be a 3D printing facility which is next to the radiological department. So it's like when the doctor says to the patient, "Ki get the CT data, head and neck, and also get me the model of the mandible. It will help me to plan."
Right. So this
So
is basically this will be more tuned in terms of the requirement for polymer made models for pre-op requirements.
yeah, polymer
For
made
pre-op,
models.
for pre-op requirements, but not the metal, the actual implant, because you can't have the hospital set up as per protocols or certain rules. You can't have a manufacturing setup like a because
Hmm.
a metal implant company, sorry, a metal 3D printer, a DMLS for that matter, or maybe an EBM or any technology wherein it manufactures and it also produces fumes. It can't be set up in a hospital. So you're saying it's only the 3D printer, which is a polymer based printer, can be
Polymer based print,
okay. Okay.
which can only print the models as well as surgical guides for
Yeah.
the
So
resection.
I think once the planning is done, the metal part can be in an industrial zone, and that can be
Yeah.
printed in any case in most circumstances. Yeah. So do you also have these metal printers, doctor, procured by you or
Yeah.
in
So
your
we have.
facility?
Yeah, so we have our own metal printer. Not only that, we have our own polymer printer also, and we print PEEK, that is polyether ether ketone, in the polymer segment, and titanium is there for the metal segment.
So that is where is this facility that you have been able to set up?
So the facility is in the Nagpur only. It's in Nagpur. So presently, I am in the facility only.
Acha, acha. So this is a facility. It has to be in an industrial zone to set up, or
No,
obviously when
because no, it's not required, because in 3D printing facility you have clean room setups, and you are not producing any waste as a pollutant. That is why you can have it.
and how old is now the organization that you have been able to set up actually, Dr.
So
Pawan?
we started in 2020 June 14th.
Okay. So with various different materials, are you also working with various institutes for in terms of research and development? For example, hydroxyapatite is also one one material, and there's a lot of promise that the material sees. So, so are you also working with various research institutes to also look at coming up with these materials? I'm sure in various institutes in closed doors, there's a lot of work happening. So, is that also your area of interest going forward?
So, see, hydroxyapatite is actually not at all a new material. So, the first hydroxyapatite was used in 1920. And this hydroxyapatite, which is a compound of calcium and phosphate, is generally being sold by different companies like Dentium, Surgiware, and they sell it in the form of blocks. And this is also one more material, that is tricalcium phosphate. So these are the two materials which are sold by the company. Whenever there is a resection in the mandible, then either the bone is taken from the body, that is autographed from the same person's body, that is taken from the iliac crest. That is one option. Second, people go for autologous bone from the Cancer Tata Memorial Institute, Mumbai. And in the third case, whenever there is implant placement and there is no bone, when you take out the tooth, the root also come out. In that case, they go for these Surgiware or Dentium or Biocare, Biometalante. There are so many companies now. They provide this hydroxyapatite and tricalcium phosphate. They call this as a biphasic calcium phosphate scaffolds. Biphasic means just both the phases are present. That is why they are saying biphasic. Now the problem with tricalcium phosphate or hydroxyapatite is that there are so many companies. Even Sri Chitra is selling the technology at around some lakhs. They said that, but the question that they asked me is that, Pranav, can you sell it? Is the question. So what happens now? Tricalcium phosphate or hydroxyapatite is a ceramic material, and our bone is not only ceramic, but it has some ductility property also because of the collagen which is present in that. Now, when we replace the segment with the hydroxyapatite block, it cannot really take the load. And how we are going to fix the hydroxyapatite and how much time it will take to regenerate. So generally, it takes around three years for hydroxyapatite to because it doesn't degrade at all. The degradation is very slow, and that is why you have the market of titanium. The patient cannot wait for. So for some implant placement things, people are using hydroxyapatite and tricalcium phosphate, but they are very old materials. Just people are coming to know about it. But if you see research papers on bone tissue regeneration, you'll find from 1999 people are making these structures. That is why bone regeneration requires some new kind of materials. There is one material called polycaprolactone. It's a polymer which melts at 60 degrees Celsius. Is a fabulous material for bone regeneration, and even a company from Germany has released the material also. But some studies there, it's just they've not commercialized it, but they've said that they have done some studies. But the thing is that, see, in India, no one will be able to buy these scaffolds because I think that's around some €1,000 for 125 grams of material. So that is the biggest barrier. So regeneration will take so much time to come into the market where it's actually regenerating the mandible bone in case of cancer cases, so that it doesn't have any problem for chemo radiotherapy. And then the bone is so strong that actually you can go for load bearing implants, that is putting the titanium implants, and you can give the abutment and the crown in that. So that will require, that is why if hydroxyapatite or tricalcium phosphate is so successful, why titanium will come into the market. Why people will go for that? It cannot, its mechanical strength is only 12 megapascal. 12
Very,
megapascal is nothing
very
actually.
true, doctor. I mean, and that's the reason why universally titanium is a better choice. Otherwise, things would have been.
Titanium actually is a better choice because it has a very low density, is very strong at even if it is porous. And the main advantage that titanium has, which SS316 or cobalt chromium doesn't have, is that it is MRI compatible. So you cannot go for MRI if you have stainless steel 316L, because it's magnetic and it will just come out during the imaging. That is why titanium is best. It doesn't corrode. It's very light in weight. Even you can go for lesser thickness for areas like CMF, where if you take huge thickness for titanium, it will palpate outside the body, and people will come to know that there is something. Even for orthopedics, titanium is good. For ribs, it's good. So in some area, however, polymers are taking better advantage. Like for plastic surgery, you cannot have a chin implant made of titanium because it will be very very stubborn, and our chin is little soft. You cannot have titanium angle implants, titanium nasal implants. Titanium orbital floor is also a question, and in that case, you have some polymer materials.
So peak is more prominently being used in orbital floors and
Peak is a new material. Peak also is not a new material. Peak people have been using, for cervical spinal cages, in that they have a block kind of a thing, and they machine it using CNC. And uh, for cranial implants, Peak is a better option because it will not heat up when you go out in the sun. And in titanium, that is a major disadvantage, because these farmers, when they go for farming, then the solution that the doctor provides is that they need to have a towel, a wet towel, and they need to wind it around the head so that they don't feel the heat. Secondly, you have some sharp edges in titanium that might intersect with the soft tissue and will have a problem of like aching, something like that. That is one of the disadvantage in some of the areas. In some areas, titanium has advantage, like in load-bearing areas. Peak or any polymer cannot sustain the load-bearing masticatory cycles, or even if for knee implants or for hip implants, a lot of load is going to come, and it has to sustain 1 million cycles, which is fatigue cycle, which polymer cannot sustain.
very true. Thank you so much, Doctor. I think you have covered, you've been able to cover almost all the areas of, that successive processes that is required for 3D technology, and also congratulating you for all the good work that you're doing in terms of setting up this service center and also offering services with your innovative ideas in terms of taking the course forward. Thank you so much, Dr. Pranav, for your time, and I wish you a great success going forward. And I think also very very important is everybody is also looking at entrepreneurs, setting up the pathway for other entrepreneurs, also to create jobs. That's an area that everybody is also looking at in terms of seeing how these centers can be efficiently structured and built with time, so that there could be more biomedical engineers and doctors who can take the benefits of this facility. So thank you so much for your time, doctor, and wishing you all the very best and a great success. Thank you so much.
Thank you, Dr. Shibu. Thank you very much.